real time what can we achieve by using the performance ESI. Afterwards, and very important, whenever you discover what is actually your bottleneck, how you should overcome the bottleneck, we have here a list of 10 best practices that you can use on real scenarios. This is based on our experience of improving the performance of applications. Afterwards, we have, let's say, a schema where you can actually use on your projects whenever you are delivering applications, what you can use on a daily basis on for a specific point in time to make sure that your application is performant. And finally, we have a Q&A session. This Q&A, we advise you to use the material that you already received. In this case, could be through the WebEx chat or through the document, and collect there all the questions that you want to be answered during this WebEx. In the end, we will go through all the questions and provide the answer for them. Well, let's start by describing what we consider the performance of an application. Well, for us, the performance of a web application, it's something that we, as a user, always take into consideration. We want always to have a fast response and effective response whenever we are using a web application. From the user point of view, if we are waiting more than 2 seconds, we will see the frustration. We will see the frustration of the user. And this is not just for an application built on top of OutSystems. This is a standard web application. Meaning these 2 seconds is our target. But don't forget the 2 seconds. This is from the moment that we request something until the moment that we get the response. Whenever you are interacting with an application, you send a request and you get the response. This is the time that is spent to measure this performance. Why is it so hard to achieve a good performance for your application? The first thing that is very relevant, developers need to be aware what is an application that is slow. They need to understand that sometimes the application is slow due to some patterns that they are using, or due to some of the limitations that the business is adding to the requirements. And this is very relevant for the moment that you are building the functionality. Another thing that is very important is that not always you are in control of everything that is around the users of an application. You can see a web application be divided into several layers. We are going through the device. It can be a laptop, a desktop, a smartphone, an iPad, or a tablet. Afterwards, we will have the network. Either you are using a cable or wireless or a network through GSM or 4G or so. And we have the application server, where you actually implement some of your business rules. And in the end, we have the database. Of course, in the middle, you can have more layers like external systems also, but the basic usage of a web application, it's the 4 layers that you can see here. From the server side, and you can see the server side here, the application server and the database server layers. The server side, it's quite difficult to drill down and understand why you are getting slowness in that specific place. But we have now, through this webinar, some useful tips that you can use to go through this process. Just to recap, whenever a user is using the web app, you have the network that is used to send the request, that is used also to download the response. In here, the download the response, it's download the content of the response. You have the server-side logic, that's the second point, and the server-side logic, it's the one that we are going to focus. And you have another layer, that's the client side. Related with the request send, content download, and the client side, we are not going to cover during this webinar, mainly because we have another webinar that was delivered 1 month ago by a colleague that you can use to go through these other layers, and will be very useful to understand why you have slowness there. This webinar will going to focus for the server-side logic. Now, let's go and now understand what the OutSystems platform already provides and what we can achieve with the information that we are collecting. By default, the OutSystems platform collects several logs. In this case, you can drill down into individual logs that are kept during 4 weeks. This is configured, the 4 weeks, but by default, when you install, you get the platform installed either on-premise or on our cloud environment, you will get the 4 weeks by default. Afterwards, we will have a rotation on the logs, meaning that you are going to lose the oldest week and you are starting a new week. And this information is going to be collected individually by eSpace and extensions. Of course, if you are willing, you can disable this information to be collected using Service Center, one of the tools. But by default, it's always enabled. OutSystems platform also aggregates this information. You can see it individually during this 4 weeks period, but you can always get the information in an aggregated view. But in this case, it will not be rotated. You always have this information available. You will see afterwards where you can get it. Also, something very important, whenever you detect the need to add customized logs, you can use it. And for this, we have the feature of audit actions. And in this case, you need to implement some logic that we are going to describe, but through this feature, you are able to extend the log mechanism, but still within the platform. What you can get from the logs, we have the general log. It's something where you see system logs, generic or specific application logs, and we will see there also queries to the database, either internal database or external database. And in this case, it's very important to understand that only queries that are taking more than 200 milliseconds are going to be logged. If you need to get this value or this threshold a little bit lower, it's possible to get it. If you actually need it, please send an email to our support team, and you are going to get how you are able to configure this threshold to be lower than the 200 milliseconds. We are also getting logs, the view state size. The view state, as you may know, it's a piece of information that is traveling from the request into the response. We are getting also the session size. Session, it's stored at database level, and we need to understand that the session size is going to impact the performance of all the requests. Timer logs, we can see how long a timer took to execute. Integration logs, whenever you invoke a web service or through a web reference, or you expose the web service, we will get also this information logged. Screen logs, whenever a user accesses a screen, we are going to get this information. We will get the time that it took to render or to execute the logic on the server side to actually provide the information to the user. And here we have two types of logs. We have the submit and we have the Ajax. Two different uses of a screen. Of course, this depends on the way that you build your own code. Extension logs, here we don't have any kind of threshold. Whenever you are using an extension, either to perform an integration, to perform some data transformation, you are going to get this action logged with the corresponding time that took to get the response. We also have the process logs. This is mainly related with the business, the BPT, business process technology, and email logs. The email logs, why they are relevant, as you may know, this is an integration with the SMTP server, but they are relevant because sometimes you are going to get huge emails related with the size. This is relevant because this can take more than expected time to create the content of a specific email. What kind of tools do we have to actually go through the information that we just described? Well, first of all, we have the Performance Monitor. Performance Monitor, it's a tool that is accessed through lifetime, and this is a built-in. It comes with a platform. It captures the end user performance from the moment that the user requests until the moment that the user actually has the information available to use through the browser. And because it uses aggregated information, it will be very useful to detect trends. Imagine that you are releasing a new version of your application. You can see if the new versions improved or decreased the performance of a specific application, a specific module. And because it measures the end user experience, we need to go through the layers that we described previously. In here, we just group them into 3 layers, just to simplify. We have the client side, we have the network, and we have the server. The first screen that you are able to see here, it provides the overall user experience. It's the combination of the 3 layers. If we drill down, we can go and see the client. The client, it's everything that happens on the browser side. We can actually go through the detailed information and see which browser was slow, which browser was fast, which device, which operating system, because we can have different behaviors depending on the browser that is used. Or the network, it's everything that is going to be outside the client and the server. It's the network, it's sending and receiving the requests from the client to the server. And here it's relevant whenever we are using a 3G or a 4G or a GPRS, it's expected to have some performance penalties when compared with the Wi-Fi or so. And you can say that through this dashboard, you are able to understand why the user is complaining or why the specific functionality is slow. Perhaps it's due to the network that is being used. And finally, and again, this is what we are going to drill down during this webinar, it's the server-side logic. For the server-side logic, most of the times, the biggest impact is whenever you need to go to the database or you need to perform some kind of integration. But there are more than just these 2 items during the server-side logic, and here you are able at least to see them combined. This is what you get through the Performance Monitor. Another tool that, again, this is built in, again, the Service Center. It's where you can see the individual logs. It's instead of the aggregated view like we described previously with the Performance Monitor, here you have the individual logs, are the ones that are kept during the 4 weeks. It's very useful to drill down into specific executions of an element, because we can go and filter by specific space, a specific moment in time, and even through a specific element, a query name or so. This is what we are going to get. Through the UI that you are seeing, you are not going to see the view state and the session size, but if you drill down through the export to Excel, you are going to get this information. If you drill down to export through the Excel file, you are going to see the view state size and all the session, and also the session size. But this is a raw evidence of the logs. It's very difficult to act upon on what we are seeing here, because it doesn't allow you to create a notion of a dashboard. Where should I invest to simplify or to improve the performance of my application? That's why we have a custom tool, a tool that is available from Forge that you can download and install. Actually, this tool, it will run on top of the Service Center logs, on top of the individual logs. Through this tool, you'll be able to go and create this notion of aggregated view through a couple of dashboards that are able to, in real time, allow you to understand where you have the bottlenecks. When you install the Performance ESI, you'll end up with a screen that allows you to understand how many servers do you have and which servers do you want actually to perform this performance assessment. Sometimes we have bottlenecks when using a specific server, and when comparing with other server, it's everything okay. That's why you have the chance to actually understand which of the servers you want to get the information from. Or, first of all, let's see the overall. Let's select both. After this, you have an option to select the screens. And by selecting screens, we have on the left side, we will get the list of applications that actually have some kind of screen logs. And you have a couple of options. You can select the top, how many screens you want to see here to perform your analysis, and which week do you want to perform the analysis. As you recall, like I said before, we have the 4 weeks kept, and here this is which of the weeks you want to get the information from. Whenever you do this, we will classify each screen within the applications that you select into 5 different categories. You have what we say the very slow, that everything above the 6 seconds, and don't forget, this is only server-side logic. Above 6 seconds, this is very, very slow. Between 4 and 6 seconds, we have pink, and we call it just they are slow. Between 2 and 4 seconds are acceptable. Fast, they are between 1 and 2 seconds, and very fast, they are below 1 second. Don't forget that this is just server side. On top of this, we need to have the other 2 layers that we described previously on the performance monitor. We need to add network and also the client side. Everything together, it should be below the 2 seconds threshold that we described originally. We have also here a split between Ajax and screens. There are 2 different types of hits, and we expect also to have different type of response, because Ajax tends to implement logic that are lighter than the screen hits. Of course, this is by default what you can get, but we also enable some kind of configuration. If you want to ignore some of the screens, imagine that you have a screen that is an outlier. You can ignore them above a specific threshold, or if you don't have hits, or if you have just one or two hits, you can remove them from the analysis. This is done through the configuration. Once you, through the dashboard, select which of the screens you want to start working on to understand why a specific screen is slow, you will get two areas for analysis. You will have a dashboard that on the left side you will see the distribution of the screen hits and also the distribution for Ajax hits with the average for each of the hits. Also, you will get the average of the session and the average of the view state. And here, session and view state, we have the thresholds defined with 10Ks for view state. Above 10Ks, we consider a problem, and for the session, it's above 5Ks. You have a chart where you can see a timeline of the performance for each individual performance. You can get the timeline of the execution for a specific period with the performance associated to it. And down below, you have the list of the information that it was executed through the server. And this is crucial. This is the point where you actually are able to understand why the application server-side logic, it's slow, it's performing bad. We have the aggregation here done through access to the database, it's the slow SQL. We have everything related with extensions and web reference. As you can see here, we have the first block for the screen, access mode screen. We have 31% related with database access. It means that the time that we are spending just to get information from the database, it represents 31% of the overall time that we are spending to get the request done to afterwards send the response to the user. For the extension, we are spending just calling extensions 10%. Web reference, it's very fast. We have several web reference, but it's only 0%. It means that it's not relevant to analyze this. And we have the remaining. The remaining, it's 59%. And the 59%, it could be access to database faster than the 200 milliseconds, the threshold that we have configured in our environment, or business logic. If we have a complex business logic, we will end up with a huge percentage there. The 59%, it's something that we need to understand better what it represents. I will talk about a little bit later how you can get this information detailed. For the Ajax, it's exactly the same. We have also the distribution using, in this case, the extension, the slow SQL, and the web reference, but the weight is slightly different. In this example, we have only 8% for extensions, 1% for SQL, and for web reference, we are still with 0%. It means that 91%, we don't know exactly where we are spending the time, and we need to drill down using the technique that I will describe afterwards. The dashboard, it's what we just detailed, the 10Ks for the session, and view state 5Ks. And don't forget that the view state is going to prevent latency when sending the request and getting the response back. The aggregates, it's what we described previously, slow SQL, the extensions and the web reference, and also the user-defined log type. This is the feature that we have to add a drill down into the no evidence found package. We have a couple of techniques that we are going to describe afterwards to allow you to drill down into this. You can also, instead of just looking into what is the aggregate usage of the database, you can expand this and see actually what queries were used to calculate this aggregate view. Also, for the extensions and the web reference, it's exactly the same. You can expand the logs and get the details. In this case, we have 7 queries that were used to consider the overall weight of the database usage. And you can afterwards get the percentage of each individual one. In this specific example, our focus should be to understand why the first query is spending 8% of the overall time. And by doing this, we need to drill down and apply some changes. Something that also is relevant to go through the next slides. Another feature that we have, instead of using the aggregates, we can actually drill down into the logs. Don't forget that the logs are individually kept, and we can, through the performance ESI, go and check why we are spending time or why they are fast. In this case, if you drill down to a specific screen, we can see, this is just an example, but we have 3 extensions that we used, and they were very, very fast because they just took 0 milliseconds. It means through the platform point of view, it was just invoke the extension and get the result immediately. The weight of this into the overall, it was very, very tiny. How to customize performance CSI with extra logging. As I described previously, you are by default going to end up with a percentage of unknown usage of unknown logic. And here, if you get a huge percentage, but still you want to understand why this is slow, we advise you to go and add to your application code some patterns that are going to allow performance CSI to group a specific area of code and combine these into the other logs that are already collected by default platform. In this case, the pattern should be to create an audit, to add an audit action into your flow. But first of all, you need to collect the time. You collect the time by using an extension with the ticks from the operating system. You combine this with the audit action, and you need to write down a message. And the message must contain what we have here. You say what we want to collect. You can say cycle. Then you need to add the message took, and you need to add the executed time in milliseconds. And by using this technique, what you are going to get is the information also available through the performance ESI. One thing relevant, this is also to make everything easy, it's to round your execution time, round it to 0. Avoid using any kind of decimal values. Performance CSI is going to use this, but this is going to end up also into the Service Center general logs. It will be available there, but performance CSI will be also knowing, is going to also collect this and combining into the existing logs from the platform. How you are going to see it? It's through this pattern. You add here to the existing logs from performance CSI, you will add our custom logs, and by doing this, you will see that that portion of code is going to represent a percentage from the overall performance. By doing it, you will reduce the no evidence found. That's the goal. You'll create some segments into your code to actually try to have the no evidence found close to 0%. What I just described, of course, it's available through the tool. Let's try to see the tool in action. Don't forget that you are able to download the tool from Forge, install it into your own environment, and by doing it, because all the logs by default are already available, you will get what you are going to see, this demo, immediately available through your own performance ESI. And like I just described, you have here a couple of filters that you can use. You select which application, you select the week, select the top, and here we have the top, in this case 50 screens. Let's try to focus on specific screen, and the two that we have here, they are the worst screens. And here the overall time, it was 150 hours for this specific week. It means that the server took 150 hours just to answer to the request to the user. This is server-side logic again. And in this case, it was close to 100 hours. We can also see that both either the screen and the Ajax, they are slow, close together, and let's try to assess why they are so slow. You can click, and now you'll drill down. You can see immediately here the distribution. We don't have, or almost none, requests that are the threshold that we consider good. We have some of them, they are very bad, and here the huge percentage is also very bad. If we try to understand why, we will drill down and see down below that the queries represent the 31%, and the no evidence deal with the 59%. If we want to know which queries, and in this case, we advise you to tackle these two first. Of course, this is a huge percentage. Let's try to see in detail which queries are we talking about. You click expand, and once you expand, you'll get actually the query that was not working properly. Or in this case, it was working properly. It's going to fetch data, and most probably with good quality, but it's taking a lot of time just to do it. And represents 80% of the overall time to execute this. From the extensions point of view, we can say that this specific extension represents 10% of the overall time that the application took just to display the information to the user. And from our point of view, you should go and try to tackle this specific query and also this specific extension. You need to understand why they are slow and how we can improve them. Now, this is the moment that you need to go and check the code. This is the evidence. The bottleneck, it's here. The 80% that we have here, this is the evidence that is slow. Of course, the 5% are also relevant, but we need to start on what we consider the biggest pain. Of course, that the Ajax it's the same. The Ajax detail it's exactly the same, but you can get different results. In this case, the extension, the same extension, instead of taking 10% of the time, in this case, it's taking 6% of the time. For this specific use case, we don't have the usage of the custom logs, but the custom logs will be useful also to understand what was outside the evidence that we are seeing here by default provided by the platform. Let's continue the presentation. Now, once you detect that is not working properly related with the performance, either a query or an extension or a web service, you need now to change your code. You need to know exactly how can I improve the code to be performant. You already pinpoint what was wrong, let's say the query, and now how can I change the query in a way that is going to get a better performance. Let's try to do this using 10 rules that we are going to describe. Of course, whenever you have the need to adapt, you need to choose which of the rules it's best for that specific use case, or you need to use your experience to understand different patterns. Here, we are going to explain the top 10, and most of the cases are going to be useful whenever you have the need to change your code. The first rule is that sometimes you are fetching more data that you require. The second is you are not actually going into you are not going to take into consideration the number of records. The first is the number of attributes. Second is the number of records. Third, it's related with the usage of inputs. Let's see how we can improve if we are using always the same inputs. Fourth, we have the inefficient data preparation. If we are going to take a lot of time just to collect data to prepare the page, let's see how we can improve this. Whenever we have the need to go with advanced queries, we need to be careful because the code, the SQL statement is not going to be improved by the OutSystems platform. This is mainly responsibility from the developer to be aware of the performance penalties, and here we are going to describe a little bit what you can consider actually to get a better performance. Another point that is very inefficient, and we are going to describe how to overcome it, it's whenever you need to filter and sort the data that you fetch from the database. The next point is related not with the database, it's related with the information that you have available to the page, not just the database access. The session variables will be the next topic. And almost closing to the end, we have a pattern that we consider very bad from the server point of view. It's the massive string transformation. And the last one, it's heavy screens. If you have heavy screens and you need to load all the data, let's see how you can actually achieve this with better performance. Let's try to drill down into each individual best practice. So first of all, you are fetching more than you need. In this case, your query is slow. You already know that it's slow, and what we advise you is that you should go and try to understand if we can add a limit to the number of elements that we are fetching. This, of course, it's going to if not going to be solved, it's going to end up with unnecessary CPU usage and also I/O from the database point of view. The database will slow down to get the response that you are asking for. How can you actually improve this? You should consider to set the number of records that you want to fetch from the database, and you can see it like if I'm getting only one record because I'm trying to understand if the information exists or not, let's use it. Let's add the max records into the attribute of the aggregate or the simple query. It depends on the version of the platform that you are using. This is a very simple technique for aggregates, but the same it will be for the advanced queries. If you need to, for some reason, go and fetch information using the advanced query, bear in mind that you need also to consider adding a max records limitation into your query. We have here a representation of the Oracle statement and the SQL statement, but both are going to be used to limit the number of rows that you are fetching from the database. Another thing that is relevant related with advanced queries is the fact that if it's required to get the number of records, you need to create a second query just to get this information. Please don't consider to use the same query because you will end up with a huge performance penalty just because you are not going to use a second query. Other point that is relevant for you to know, whenever you need to get the number of records from the database for a specific query, you can use the query.count. This is a property that you can get whenever you have an aggregate. What is going to happen through the OutSystems platform is that we are going to actually generate a second query to the database with the same SQL statement with a little twist that is adding a count. It means that for an aggregate, you can end up with two different queries that you are sending to the database. And what we encounter is most of the times, you don't need to actually know how many records you have. Most of the times, you only need to know if you have records or not. And with a little technique that is replacing the query.count equal to 0, if you replace it by query.list.empty, it will get the same impact from the logic. You end up knowing if you have records or not, but from the database access point of view, you are going to reduce one query. If you multiply this by the number of queries that you have, you will get a huge improvement. This is not just for the advanced the aggregates. This is also relevant for the queries that you are going to customize by hand using the advanced queries. Most of the times, when you have an order, you don't need to go and apply the order by the number of records. You want to know the number of records despite the order of them. This is relevant when we are moving from a customized advanced query to a second advanced query where you only want to add the count. Please consider to copy the statement in a smart way. Remove everything that is not relevant to have on the second query that you are adding. This is an example where you have a lot of transformation related with the result that we are getting, and this is not actually relevant for the point where you have the count. And this is what we consider simplify the usage of your second query to get the count from the database. Another rule is the usage of inputs. Whenever you have the same query executed several times or a specific action, user action, executed several times within a specific period, you're going to end up with the same result, but always relying on the logic, either logic from the application server or logic from the database. What we advise here is to use a feature from the platform that is the cache. Whenever you need to get the same result within a specific period, you can rely on the previous result. By adding a property into your query or action, you can easily get a huge improvement because you are not going to execute the same logic. You're going to reuse the information that was stored in memory. Just a warning here. Of course, this is a huge improvement, but if the business is always changing the rules, meaning that whenever you go and fetch the information, you will get, with the same inputs, you will get different results. You cannot cache during a long period. You cannot consider hours, days, seconds without talking with the business. You need to understand very, very detailed how the business is going to react on getting the same result, and just upon on the response, you are able to actually configure this without losing any feature of the application. Like I described, you can consider hours, 24 hours. You can cache the results for 1 day. You can cache the results for 1 hour or doing the session user. Or you can, in this case, this is for other element besides the queries and the actions, you have the weblogs. You can say, oh, I want to cache the result of the render of this specific weblog for 1 minute. You can explore what kind of elements could be cached. You have also screens and other elements, but again, use this with caution because sometimes you can jeopardize the business side of your application because you are not always getting the latest information that the user is requesting. This is just an example. You can easily optimize a specific query if you know upfront that you are going to get always the same result within the same period. If you cache it in minutes, you reduce the number of hits for that specific query to the database because you are only going to get once the information from the database, and afterwards we are going to rely on the server. Another example is inside the screen. If you have the same logic always available through a weblog, let's cache it and you'll get an improvement. And here it's the example related with the screen action. You can easily, based on the information, the inputs of your action, the information that it was executed previously, you will get the same result within the minutes that you defined in the attribute caching minutes. Bear in mind, this is always based on inputs. The inbound attributes of your query, of your action, of your weblog. And this is how we can improve. In some situations, we can use a technique that is to force the cache. If you know up front that I want to cache this during a specific period, but from time to time I want to make sure that I am able to refresh, we advise you to use a technique that is to pass a new parameter that is not business related, but this is related with the cache version. We can from time to time control in a different layer, we can control which cache version we want to use, and because we are passing this into the actions, into the queries or so, we can force the information to be fetched again, executed again. This is within the cache period, we can force the cache to be invalidated by using this technique of adding a new parameter. Another item that is very important for you to know is data preparation. Whenever you have a screen access, whenever you have the need to render the entire screen to the user for the first time, you are going to actually collect information from different places, let's say from the database, and try to provide this information afterwards into the UI, into the user interface of the screen. And one of the points that we encounter that is very, very often used is the amount of queries that you are performing within the preparation. This is going to most probably end up with a pattern that you have a for each within the preparation, meaning that you have some kind of control. It can be by a query, and you have a for each, a cycle that is going to iterate through the result set, and for each element you are going to perform one or several queries. This will end up with dozens, hundreds, thousands of queries just to prepare data to be displayed into the screen. Also, some of the queries are going to be executed during the screen render within the table records. This is also something that is going to jeopardize the performance of the data preparation. How can we actually go and improve this pattern? This pattern should be considered to be improved using a technique through proper joins, meaning that instead of having several queries and the cycle, you can just, with only one query, combine the result set and get what you are willing to get for the screen to be displayed afterwards into the screen. Also rely on some SQL functions. As you may know, there are several functions provided out of the box through the database engine that could be used here to optimize the number of requests that you are sending to the database. Also, consider that in some situations it's better to have two different queries completely different or with different logic and only execute one of the queries depending on the information that you are going to display afterwards into the user. Instead of having the two queries executed and during the screen render, you are going to choose which of the results that are you going to display to the user. You will always end up spending time going to the database server one more time than you requested up front because you are not using one of the result sets. And in extreme situations, you could consider to use specialized screens. If you have a screen that is complex in a way that in some situations you are showing one section, another situation you are hiding that section and showing another one, perhaps the screen should be different. Two different screens for showing different information, not combined with a power screen where you can have everything, but it depends on the user, it depends on the role, it depends on the type of information that you have. Perhaps you should dedicate different screens just for that specific use cases that you are preparing. One example, it's the one that we have here. Imagine this situation where you have most of the columns that we are showing here, 4 different options. And you can see the 4 different options like a query, the server side, with 4 different joins, one for each element. The solution, of course, to simplify the way that the information it's collected through the preparation, it should be to create 4 different queries, the preparation, to make sure that once you are going to display the information to the user, you only are going to use one of the result sets. And actually, it's the only one that you have. The other 3, you don't have them because you skip them during the preparation. Another solution is to, of course, like I described before, instead of having one power screen, you can split this into, in this case, 3 or 4 screens. And the screens are going to be simple to maintain, simple to adapt, and will be quite fast to execute, because you are not going to have the overhead of getting all the data that is not relevant to be displayed to the user. Another tip that we have here to provide, it's related with inline parameters. In some situations, the SQL statement is so different that it's not going to be optimized by the database engine whenever we are sending the request to the database engine. And what we know, based on an analysis that we did before, it's that we need always to be aware how the database is going to interpret the information that we are sending to make sure that is going to optimize the way that is going to be executed. In this case, well, it's through the execution plan. It's going to make sure that we are going to use the previous execution plan because the query statement is not different. And if we are using inline parameters, we will end up, whenever we are sending the request to the database, we are going to end up with different execution plans because the SQL statement is going to be always different. The solution is to have some specialized queries, and in this case, specialized queries, it will be through some variables that you can control. Instead of adding some filters or adding some joins dynamically, we don't advise you to go and inject the result of a query into another query. We should advise you to create a complex query. This is complex, but it's going to reuse the execution plan. And finally, it's a technique. This is available through the database engine. It's to, in Oracle, use materialized views, in SQL Server to use indexed views, or Oracle again use the global temporary tables. In this case, you can get huge performance improvements by using these kind of techniques, but you should evolve your DBA. In this case, please we advise you to talk a little bit with your DBA to get this technique in place. You will get better results, but we advise you to involve the DBA on this decision. This is an example where you have a list of IDs. This is what we say inline parameter using in an advanced query. It's in this case 2 different inline parameters with list of IDs. What we want is, of course, to filter based on the IDs that we are receiving. What we know is whenever you are sending this, if we are not doing it properly, the database engine is not going to optimize the query. This is the common pattern. It's to use the where clause where you have the list of IDs. How to overcome this? It's using the temporary table that we described previously, where you have the with the ID, the ID table, and afterwards you have the select. And the select is going to be straight pointed to the IDs that you want. Another technique is to, instead of using the temporary table, it's to use a query to get the IDs from the statement and to just make sure that they are within the ID that you have on your master record. This is not using the temporary table, this is using just a subquery to get the result. But the execution plan, it will be optimized because in the end you will have 2 different queries, one that is very simple and the other one that could be the master query. It will be slightly complex, but it's going to reuse the database execution plan. Another advantage is that you don't need to go and create a comma-separated list. And this is the solution in place, how you can use it. You have here the SQL statements through the advanced query, and here down below you have the usage of the subqueries and the temporary table. Another item that is relevant for you to understand whenever you are going to optimize is the inefficiency of using filter in starting. Whenever you use filter in starting, you need to be aware what kind of attributes are you using to perform this operation. If you need, for example, just to cast inside your query, it's always going to add some bottlenecks, performance bottlenecks into the query execution. That's for sure. Also, if you are going to perform a like over a text, it's going also to add a performance bottleneck and also the lack of indexes for the columns that you have the filter and the order. And last but not least, it's maintenance plans. Of course, most of the times, developers are not going to be responsible for making sure that the execution plans from the database point of view are properly configured and running accordingly, but this could jeopardize the usage of the application, mainly in production. We advise you to make sure that you have the maintenance plans up and running. How to optimize the filters? This is what we described previously using the like. We should, whenever possible, to avoid using this kind of filters. If you need to have some kind of cast, try to do it outside the query. If you need to transform a text into an integer, please do it outside the query instead of doing it inside the query statement. The indexes, like we described, they are very good to improve the performance, but they are going to create a slight overhead whenever you need to insert or update information into that specific entity. This could be achieved, the index, you can manage index through the Service Studio. Service Studio is able to create the index based on the information that you need, but in some situations you need also to involve the DBI. This is also important to know. Not always a specific index is going to improve like you expect. If so, please involve the DBA, and he's going to explain what kind of index are going to improve the experience of a specific statement that you want to execute. In some situations, an index could be also a combination of several attributes, not just index over a specific attribute. It could be a compound index. And for a specific query that you know that you are going always to get this kind of usage, we can take the advantage of adding the index like this. Again, involve the DBI, especially for the maintenance plan. This is very important, but also to make sure that the index that you have, they are going to be used properly. Sometimes if you have index but they are not being used, it's better to remove them from tables instead of having them. Another point is the scope data. Scope data, it's related with the information that the application needs to perform some kind of request. Whenever the user is going to request from the browser some information, we have what we call the view state. We have a piece of information that we need to send to the server. This information is crucial for making sure that the logic is going to be executed like we expect. And if we are not going to be aware of which kind of information we are going to add to the view state, we can increase the latency of the network traffic that is going to be used to get the response to the user. This is something that whenever we are building our code and whenever we are going through the performance of our application, we need to be aware. Let's try to reduce the view state size through our application logic, and if you reduce the view state size, for sure that we are going to get the information of the view state on a stage that we want. And in this case, is to reload queries. Please, instead of using the result set, try to reload, and if needed, execute some actions instead of using the information that it was previously fetched, and also making sure that you use the parameters from your screens. And this is how you should think the view state. It's making sure that you reduce the information like we are describing here. Don't try to go through the preparation to the screen action, making the usage of the information. Try to collect the information again or pass it through the screen action using an input. Session variables, this is crucial because all the requests are going to be handled by the platform using a specific database. That's the database where we store the sessions, and this is a bottleneck because we can always go once to the session and all the other requests are going to be hanging until we get the response from the first one. If you have the session quite big, it will jeopardize all the requests that you are sending to the server. How you should reduce this, making sure that you are using low number of session variables, and if you need to store extra information related with some elements of your logic related with the session, you consider keep this into a different element instead of adding it to the session. Another topic before the last, it's the massive string transformation. This is going to use the logic from your server. This is not going to jeopardize the database. In this case, it's going to jeopardize the way that the server is going to handle the request. We detected a pattern that is very, very relevant to describe. Whenever you have string manipulation, we are adding several elements to a string with plus. You can get some performance penalties, and if you use an extension like the string builder, you are going to get better performance. Of course, we have here an example where we are creating a flat file with 9 megabytes. Imagine this through just a couple of assigns or just one assign with several elements there. This is where the performance is going to be jeopardized. And the last topic that we have is, let's say, a quick win. If you have a huge screen, a power screen with a bunch of information, imagine a dashboard or so, we should consider to load information in a way that we are going to provide what we can provide immediately to the user, and afterwards collect what we can say that it's slower, but still the user is able to process the information that is already available. What we call here the solution is using a lazy load strategy. And the lazy load strategy, it can be achieved by hand. Of course, you can build it yourself, but if you go to our Forge, you can get the component, the lazy load sample, and very easy, you can adapt the existing page that you have into a structure that you will end up with the same information, but it's going to be loaded in a way that the user is going to perceive a better performance from the application. This is what we advise you as a quick win, and if you have already the structure based on the web logs, it will be very easy to implement. Finally, before the Q&A, we have the life cycle. How can you use this in your real life during your application development? Well, first of all, some of the tips that we just described and others, you can get them from our knowledge base. If you search our knowledge base, you'll get the best practices, and this is relevant for your teams and for you to understand what the OutSystems platform can do and how you can achieve the best performance using the platform. Also, try to discuss with your teams the best way to implement a complex business logic. Sometimes it's not just building the code, it's building the code in a way that is going to add the value to the user, but still making sure that the user is not going to complain afterwards that is going to wait so much time to get this information available. Do some code review frequent. This is relevant because some of the patterns that you know that are wrong, if we are not going to implement a good code review, they are going to end up into production and it could jeopardize the performance. And of course, monitor your application. Please use the tools that I just described to make sure that you understand how the users are using the application, why they are complaining, why they are not complaining, but still the performance is not good. Please monitor the application. Once it goes to production, it's relevant to make sure that you understand how the application is being used. But before going to production, we advise you to implement a load and stress test approach. Try to simulate what It's going to happen once the application is going to be live. If you do this, perhaps you are already going to collect a bunch of logs that are close to real live scenarios, and you can act upon it before going to production. After going to production, again, monitor your application. Don't wait for users to complain. You can know immediately based on information that the platform collects how they are using the application, and be aware that from time to time performance can decrease, either because you are going to release new versions and you add logic that is going to jeopardize what was there before, or due to the volume of data that you are now going to handle, this is going to decrease. This is relevant to be aware on the trends. And that's it. The next webinar that we have available, it will be related with building a lifestyle guide. But now we are going to break during 5 minutes and go through